Number 50. The basic principles of designing an experiment include which of the following? 1. Control, 2. Random assignment, and 3. Replication. So let's just break down what each of these mean step by step. So first one we have is control. So what a control or a control group is it's pretty much a group that you don't give any experimental treatment to. And then you use that to compare to the group that you do use treatment on. So let's say you had some plants and you're testing out a new fertilizer to see if it works better than your previous fertilizer. So you would need to have a control group of the plants using the original fertilizer to then compare to the group that used the new fertilizer. And then from that you could run a statistical test and you could see if the differences in height was enough to show a statistical difference. So that is going to be one of the basic principles, because you need it to determine if the experiment was successful or if there is a difference. So random assignment. So pretty much, let's say that these plants have some sort of genetic mutation, or some of them have a genetic mutation that makes them grow faster, makes them grow quicker than the other plants. But you have no way of knowing which one is which. The reason you use random assignment is to do your best to split these evenly among the control group and the treatment group. That way, well, imagine you put all of these in the treatment group, and all the plants that grow faster are put in the treatment group. It would seem like those plants grew way better, and in fact, it would seem that way even if the new fertilizer didn't really have an effect. So the random assignment is the best way of making sure that variation like that doesn't happen. So that is going to be one that we want. Random assignment is one of the basic principles. And then finally, replication. So let's say you're doing this experiment, and through random chance, which there is a random chance, all of your plants with the genetically modified ability to grow taller quicker, all end up in the treatment group. And it looks like those plants grow super tall. You want to be able to replicate this experiment. Because the chances of that happening twice are very slim. And if it doesn't happen again, and say on the third try it doesn't happen again, on the fourth it doesn't happen again, you can be pretty confident that the first one was a fluke and you got all of the genetically really tall ones in the treatment group. And so pretty much you want the replication in order to test the reliability and the probability that the first one was just a fluke. So you need the replication to test the reliability of your experiment. So that is also one we are going to want. So replication. So all of these are true, and so our answer choice is answer choice E. Alright, so if you have any questions from other tests, make sure to leave a comment and I'll make a video with the solution. With that said, if you enjoyed the video, leave a like and subscribe. This has been Investigative Math, and I will see you next time.